In this video, we're going to try to get this matrix A to look like our identity matrix I using the row reduction techniques we see here. So first we have to look at what our row reduction techniques are. So our first option is we can swap the rows. Our second option is we can multiply any row by a non-zero scalar. Or we can add a scalar multiple of a row to another row. So we can use these techniques here to try to get these numbers to look like this identity matrix. So starting off, we have our matrix. And what we're going to want to do is we're going to want to try to start with this number, these two numbers here in this first column. Try to make that look like a 0 and this look like a 0. So the first thing that we can do is we can times the second row by -5r1 to try to make this a 0. So what I like to do is I like to start off with what row is going to be affected. So it's going to affect R2, your second row. And then you're going to do plus a -5 row 1. So we know that row 1 isn't going to be affected by this change, so we can keep that the same. And we know that the third row isn't going to be affected either, so we can write that there. And then for row 2, what we're going to have is -5 times 1 plus 5 is 0. -5 times 2 is -10 plus 6 is -4. -5 times 3 is -15 plus 0. We're going to have -15. So for our next one, what we can notice is that we already have the 0, 1 here that we need for the second row. So we can do our first operation here, we can switch the rows. So what we can do here is switch R2 and R3. So we know that R1 isn't going to be changed, but we do know that R2 and R3 will be changed, so we'll switch those up here. So we have 0, 1, 4, and 0, -4, -15. So moving on, we want to try to make row 3 have a 0 here. So we can do that by using row 2, and we'll put this down here. And we'll use our third rule here. Again, we'll add a scalar multiple of the row. So in this case, it's going to be R2 times 4 would make this 0. So we'll again stick with our which row is going to be affected first. So R3 is going to be affected. Plus 4 times R2. So we know row 1's not going to be affected, and we know row 2's not going to be affected. And then we'll just write out our affected row 3. So that's going to be 0, 4 times 1 is 4, plus -4 is 0, and then 4 times 4 is 16, plus -15, that's going to be 1. So as we can see on the bottom here, we already have our bottom row of our identity matrix figured out. So now what we're going to want to do is we're going to want to take a look at our top row. So looking at our top row, we can use row 2 to get rid of this 2. So we'll write down row 1 is the one that we want to change. And we want to get this to 0, so we're going to do 1 times negative 2 would make this 0. So we'll do R1 plus negative 2 R2. So again, we know row 2 and row 3 won't be affected, so we'll keep that the same. And we'll change row 2, or row 1. So what we have is 0 times negative 2 is 0, plus 1, it's going to be 1. Negative 2 times 1 is negative 2, plus 2 is 0. And negative 2 times 4 is negative 8, plus 3. We're going to have negative 5. And next up we need to get rid of this 5, so we'll stick up with row 1 while we're here. We'll do row 1. So row 1 first, and then we'll do plus 5 row 3. So we'll keep these two the same. And fix our top row. So we'll have 1, 0, 5 times row 3 is 5. We'll have 0. So now our very last step that we need to do is we need to fix row 2 here. So we'll use row 3 again because that's our last number we have. And again, we'll use this third operation here. We'll do row 2 minus 4 row 3. And we'll fix up row 1, and we'll keep row 3 the same. And row 2 is going to be 0 minus 4 times negative 4 is 0, 0 plus 0. 0 times negative 4 is 0 plus 1. And then 1 times negative 4 is negative 4 plus 4 is going to be a 0. So that is how we get to our identity matrix. Please like and subscribe if you found this video helpful. Thank you.